So hello guys, and on today's video we are going to learn about differentiation. So differentiation, usually what that is used for is when we want to work out the gradient of a curve. We can use methods such as differentiation to work it out, and then the opposite of differentiation, integration, we can use later on when we want to work out the areas under the curves. So that's one of the main uses of differentiation. And today we're going to learn a bit about what you need to do when you come across these questions. And at the end, we'll do a question going over a gradient and how we can use differentiation to work out the gradient of a curve. But right now, we'll start with the basics. So if you look onto the screen now, as you can see, I have formulas for the differentiation. So we have y is equal to x to the power of n. So x is just being x, it's just a variable, it's an unknown, and n is just like a constant number. In this case, let's just say x is 5, for example, okay? So let's say I'll use a black pen this time. Let's say we have y is equal to x to the power of 5, okay? We want to differentiate this. So what we need to do, well, if you look at what I've put, so if y is equal to x to the power of n, dy over dx, that's the differential with respect to x. Dy over dx, that would equal n times x to the power of n minus 1. So effectively what you're doing is, in this case, you're just bringing that power down to the front. So if we do that here, we would have dy over dx, and that is equal to, so bring the 5 down to the front, so we have 5x, and then when it comes to the power bit, we just do n minus 1. So in our case, n was 5, so just 5 minus 1, and that gives us the 4. So as we can see here, if we want to differentiate x to the power of 5, it is simply just 5x to the power of 4. Okay? Let's say we had a different example. Okay, let's say we had y is equal to 2x to the power of 3. Well, we can look at the other formula we have just here, but not much really changes. So if we have something in the form of y is equal to a times x to the power of n, when a is just any constant value, then if we differentiate that with respect to x, then it will just be a times n times x to the power of n minus 1. So nothing actually changes. You just bring that power down to the front. You can times it with your constant value a, and then you just change the power, make it 1 less. So in this instance, if we do that, then we would have dy over dx. So we bring that power down to the front, so we'd get 3 times 2. 3 times 2 times x. If we put the power down by 1, that would just go to 2. And then if we just bring it all together, 3 times 2 is 6x squared, okay? So if we differentiate 2x to the power of 3 with respect to x, then our answer is just 6x squared. Okay, so what if we had one like this? We have y is equal to 10x to the power of negative 1. So with that one, again, it's the same thing. So what we do is we start off by bringing that power down to the front. So minus 1 times by the 10 and times by x. And then with this one, just remember, we're still minusing 1, but remember that when you minus 1 from minus 1, it will be negative 2, okay? So if we put that all together, we get minus 10x to the negative 2. And depending on the question, depends on how you want to write it, you can leave it as minus 10x to the power of negative 2, or you can always rewrite it like this as a fraction. It's up to you, it depends on the question, either way is fine. Okay, what about this one? Now we have y is equal to the square root of x. So what I would do for this question is, what you should do is just change this. So when you get something like this, change it. You want to make it into a power, okay? You're going to make that square root into a power because it just makes it a lot easier when it comes to differentiating. So if we do that, we will get y is equal to x a half. And then from there, it's just the same thing. So you bring the power down. So we'd get a half x, and then a half minus a 1 is minus a half, so it would just be like that. And you can also rewrite that if you want to. It's up to you. So we would get 1 over 2x to a half. Or you can either rewrite it as 1 over 2 root x. Up to you. I would personally just leave it as a half x to the power of a negative half. But I mean, it depends on what question you have. Maybe you want to write it like this. You can write it like that. It's up to you. Okay, so now with this question, we need to differentiate it. And in the previous questions, we just had just one variable. Now we have multiple, okay? We have 2x squared minus 6x plus 3. We have multiple different values here. So to do this one, it's, again, not much difference. You just do all of them separately. And yeah, whatever you end up with, that will be your answer. So for this one, if we differentiate with respect to x, then we bring that 2 down. So we would get 4x. Now, if we change the power, we would get just 1 to the power of 1, and anything to the power of 1 is just itself. So we can just rewrite that as x. So it's just 4x. With this one would just be minus 6. Now, to explain that, it would be minus 6 is because if I write it on the right side here, if we have minus 6, we can think of that as minus 6 to the power of 1. And then if we differentiate that, we would have 1 times minus 6 times x to the 0, okay? Because 1 minus 1, if we do it to the power, it will give us a 0. And then anything times to the power of 0 is simply just 1. So we're just left with a minus 6. So anytime you see any value where it's just x, it's nothing else, just x. When you differentiate it, you can just get rid of the x, and that will be the answer, okay? So just get rid of the x. So if we have minus 20x, if we differentiate that, it's just minus 20. We have minus 100x, we just get rid of the x. When we differentiate, it's just minus 100, okay? So that explains why it's minus 6. And then for this one as well, when we have a positive 3, we can't do anything with that, okay? If we have something like a 3, you can't differentiate that. It has no x value. Because remember that when we're differentiating, we are differentiating with respect to x, okay? And that is key. This is why I've been saying with respect to x, because when you differentiate, you're always differentiating with respect to a certain variable. So that is key. If there is a number which doesn't have that variable attached to it, like in like this 3, for example, we can't differentiate it. Hence, we just get rid of it, okay? We just get rid of it. So we don't include it in the differentiated bit because you can't differentiate it, okay? So our answer for this is just 4x minus 6. Okay, so with this question, we have to find the gradient of the curve of y is equal to 3 root x at the point x is equal to 4. So when you have a question like this, where it asks you to find the gradient of a curve, there are other ways you can work out the gradient of the curve, which you will learn in A-level maths. But if you have the option to choose which way you want to do it, I would say usually the easiest way is by differentiating. So in this type of question, to work out the gradient of a curve, all you need to do is differentiate the equation with respect to x, and then just put in the x value into x, and that will give you the gradient at that point. So we just differentiate, substitute in 4 for x, and that will give us our gradient. So let's do that. So we have y is equal to 3 root x, okay? So with this question, remember, it's always best to rewrite that square root as to the power of a half, okay? That'll make it easier for you to differentiate. So now that we've done that, if we differentiate with respect to x, then that will be 3 times a half, which is 3 over 2. It is also best to leave your answers in fractions. It makes it a lot easier, I find, when you're solving it. So 3 over 2x, and then a half minus a 1 is minus a half. And now we need to substitute in x. Now in this instance, because I'm going to substitute in a value, I think it's always clearer to put it back into its original form. So I'm going to rewrite this as 3 over 2 x to the half, and then I'm going to rewrite it as 3 2 root x. Okay, the reason for that is because we have to substitute in a number. It, to me, it seems a lot easier if we are going to substitute in the number when it's looking like this, rather than have 3 over 2 times 4 to the power of a negative half. That is a bit iffy. It can look a bit iffy. This to me is easier now to work out. So now we've differentiated and we've written back in this form. Now we can go and substitute in 4 for x. So if we do that, then we would have 3 over 2 times root 4, and then that is 3 over 2 times 2, which is simply just 3 over 4. So we know now that the gradient of the curve when x is equal to 4, the gradient is 3 over 4. So to do that, you can use differentiation. And there's a lot more you can do with differentiation as well, which we'll learn in our next lesson. But today I just wanted to cover just the very, very basics of differentiation. And now in our next lesson, we'll go on to more questions where we have to work out the gradient of the curve. So I hope you enjoyed this lesson, and I will see you soon.